Greetings to dear friends, thank you for choosing the BigDark channel for teaching scientific content. Please do not forget to subscribe, like, and comment to support the channel. Lightning. Lightning is a naturally occurring electrostatic discharge during which two electrically charged regions, both in the atmosphere or with one on the ground, temporarily equalize themselves, causing the instantaneous release of as much as 1 gigajoule of energy. This discharge may produce a wide range of electromagnetic radiation, from the heat created by the rapid movement of electrons to brilliant flashes of visible light in the form of blackbody radiation. Lightning causes thunder, a sound from the shock wave which develops as gases in the vicinity of the discharge experience a sudden increase in pressure. Lightning occurs commonly during thunderstorms as well as other types of energetic weather systems, but volcanic lightning can also occur during volcanic eruptions. The three main kinds of lightning are distinguished by where they occur, either inside a single thundercloud, between two different clouds, or between a cloud and the ground. Many other observational variants are recognized, including heat lightning, which can be seen from a great distance but not heard, dry lightning, which can cause forest fires, and ball lightning, which is rarely observed scientifically. Humans have deified lightning for millennia. Idiomatic expressions derived from lightning, such as the English expression bolt from the blue, are common across languages. The fear of lightning is called astraphobia. Electrification. The details of the charging process are still being studied by scientists, but there is general agreement on some of the basic concepts of thunderstorm electrification. Electrification can be by the triboelectric effect as a result of ion transfer between colliding bodies. Unchanged arced, colliding water drops can become charged because of charge transfer between them, as aqueous ions, in an electric field as would exist in a thundercloud. The main charging area in a thunderstorm occurs in the central part of the storm where the air is moving upward rapidly, updraft, and temperatures range from 15 to 25 degrees C, 5 to 13 degrees F, see figure 1. In that area, the combination of temperature and rapid upward air movement produces a mixture of supercooled cloud droplets, small water droplets below freezing, small ice crystals, and graupel, soft hail. The updraft carries the supercooled cloud droplets and very small ice crystals upward. At the same time, the graupel, which is considerably larger and denser, tends to fall or be suspended in the rising air. The differences in the movement of the precipitation cause collisions to occur. When the rising ice crystals collide with graupel, the ice crystals become positively charged and the graupel becomes negatively charged. The updraft carries the positively charged ice crystals upward toward the top of the storm cloud. The larger and denser graupel is either suspended in the middle of the thunderstorm cloud or falls toward the lower part of the storm. The typical cloud-to-ground lightning flash culminates in the formation of an electrically conducting plasma channel through the air in excess of 5 kilometers (3.1 miles) tall, from within the cloud to the ground's surface. The actual discharge is the final stage of a very complex process. At its peak, a typical thunderstorm produces 3 or more strikes to the earth per minute. Lightning primarily occurs when warm air is mixed with colder air masses, resulting in atmospheric disturbances necessary for polarizing the atmosphere. However, it can also occur during dust storms, forest fires, tornadoes, volcanic eruptions, and even in the cold of winter, where the lightning is known as thundersnow. Hurricanes typically generate some lightning, mainly in the rain bands as much as 160 kilometers (99 miles) from the center. Necessary conditions. In order for an electrostatic discharge to occur, two preconditions are necessary. First, a sufficiently high potential difference between two regions of space must exist, and second, a high resistance medium must obstruct the free, unimpeded equalization of the opposite charges. The atmosphere provides the electrical insulation, or barrier, that prevents free equalization between charged regions of opposite polarity. It is well understood that during a thunderstorm there is charge separation and aggregation in certain regions of the cloud. However, the exact processes by which this occurs are not fully understood. Electrical field generation. As a thundercloud moves over the surface of the Earth, an equal electric charge, but of opposite polarity, is induced on the Earth's surface underneath the cloud. This is known as an image charge. The induced positive surface charge, when measured against a fixed point, will be small as the thundercloud approaches, increasing as the center of the storm arrives and dropping as the thundercloud passes. The referential value of the induced surface charge could be roughly represented as a bell curve. The oppositely charged regions create an electric field within the air between them. This electric field varies in relation to the strength of the surface charge on the base of the thundercloud. The greater the accumulated charge, the higher the electrical field. Upward streamers. When a stepped leader approaches the ground, the presence of opposite charges on the ground enhances the strength of the electric field. The electric field is strongest on grounded objects whose tops are closest to the base of the thundercloud, such as trees and tall buildings. If the electric field is strong enough, a positively charged ionic channel, called a positive or upward streamer, can develop from these points. This was first theorized by Heinz Casimir. As negatively charged leaders approach, increasing the localized electric field strength, grounded objects already experiencing corona discharge exceed a threshold and form upward streamers. Attachment. Once a downward leader connects to an available upward leader, a process referred to as attachment, a low resistance path is formed and discharge may occur. Photographs have been taken in which unattached streamers are clearly visible. The unattached downward leaders are also visible in branched lightning, none of which are connected to the Earth, although it may appear they are. High-speed videos can show the attachment process in progress. Cloud to the cloud, CC, and intracloud, IC. Lightning discharges may occur between areas of the cloud without contacting the ground. When it occurs between two separate clouds, it is known as cloud to cloud, CC, or intercloud lightning. When it occurs between areas of differing electric potential within a single cloud, it is known as intracloud, IC, lightning. IC lightning is the most frequently occurring type. IC lightning most commonly occurs between the upper anvil portion and lower reaches of a given thunderstorm. This lightning can sometimes be observed at great distances at night as so-called sheet lightning. In such instances, the observer may see only a flash of light without hearing any thunder. Another term used for cloud or cloud, ground lightning is anvil crawler, due to the habit of charge, typically originating beneath or within the anvil and scrambling through the upper cloud layers of a thunderstorm, often generating dramatic multiple branch strokes. These are usually seen as a thunderstorm passes over the observer or begins to decay. The most vivid crawler behavior occurs in well-developed thunderstorms that feature extensive rear anvil shearing. Extraterrestrial. Lightning has been observed within the atmospheres of other planets, such as Jupiter and Saturn. Although in the minority on Earth, super bolts appear to be common on Jupiter. Lightning on Venus has been a controversial subject after decades of study. During the Soviet Venera and U.S. Pioneer missions of the 1970s and 1980s, signals suggesting lightning may be present in the upper atmosphere were detected. Although the Cassini-Huygens mission flyby of Venus in 1999 detected no signs of lightning, the observation window lasted mere hours. Radio pulses recorded by the spacecraft Venus Express, which began orbiting Venus in April 2006, may originate from lightning on Venus. Human-related phenomena. Airplane contrails have also been observed to influence lightning to a small degree. The water vapor-dense contrails of airplanes may provide a lower resistance pathway through the atmosphere, having some influence upon the establishment of an ionic pathway for a lightning flash to follow. Rocket exhaust plumes provided a pathway for lightning when it was witnessed striking the Apollo 12 rocket shortly after takeoff. Thermonuclear explosions, by providing extra material for electrical conduction and a very turbulent localized atmosphere, have been seen triggering lightning flashes within the mushroom cloud. In addition, intense gamma radiation from large nuclear explosions may develop intensely charged regions in the surrounding air through Compton scattering. The intensely charged space charge regions create multiple clear air lightning discharges shortly after the device detonates. Physical manifestations. The movement of electrical charges produces a magnetic field. The intense currents of a lightning discharge create a fleeting but very strong magnetic field. Where the lightning current path passes through rock, soil, or metal, these materials can become permanently magnetized. This effect is known as lightning-induced remnant magnetism, or LIRM. These currents follow the least resistive path, often horizontally near the surface but sometimes vertically, where faults, ore bodies, or groundwater offer a less resistive path. One theory suggests that lodestones, natural magnets encountered in ancient times, were created in this manner. Lightning-induced magnetic anomalies can be mapped in the ground, and analysis of magnetized materials can confirm lightning was the source of the magnetization and provide an estimate of the peak current of the lightning discharge. Research at the University of Innsbruck has found that magnetic fields generated by plasma may induce hallucinations in subjects located within 200 meters 660 feet of a severe lightning storm. Thank you for being with us until the end of the program. Be sure to mention your opinions about the educational video in the comments section.